Okay, so our table basically describes to us how one substance can take on 3 different states of matter without actually changing what it is, the substance. It's still water, whether it's ice, liquid water, I'll put liquid H2O, or water vapor. It is still the same substance, it's just different, in a different state. Okay? And then down at the bottom, it just talks a little bit about solid ice has its own shape that does not change and it does not move. We knew that. A liquid takes the shape of the part of the container that it fills. So that's another thing we can add to our liquid. Takes the shape of its container. Okay. Liquids will always flow towards the bottom. They will always seek the lowest point that it can get to. A gas expands to fill the entire container that it is in. Expands to fill its container, and it moves easily in all directions. Okay, so the summary is basically trying to condense all of this information into 1 or 2 sentences that contains the most important point. So I'm going to say that one substance, water, can be in all 3 states of matter without undergoing a chemical change. Each state of matter has its own properties or ways that the particles behave. Each state of matter has its own properties and, oh gosh, I'm running out of space. I hate it when this happens. And ways that the particles behave. Okay, so for my teacher-like questions, I've got one. I usually try to set a goal to have at least 2 questions. So another question I could ask is, can water be a solid, liquid, and a gas? And the answer is yes, it can. And then my third question could be, will a liquid always flow down to its lowest point? And the answer is yes. Flow down to its lowest point. Okay, so here are my Cornell notes, guys. I don't know, hopefully this helps you. We're gonna practice these a couple times. The reason I like these is because it's a note-taking strategy that will work with any type of nonfiction text that you're reading.